Hi everybody, welcome back to the Feynman technique. So today is going to be kind of a long video, and we are going to be evaluating 8 different integrals at once. And we're going to be doing it as efficiently as possible using previously derived results. We're going to start by we're going to start with integral I5. So, all right. So I5, let's first notice that I5 is equal to this. That's stated. And that is also going to be equal to this by King's property or by the substitution that u is equal to pi over 2 minus x. You can easily get that this is equal to this. And this is I7. This is integral 7 right here. So these two are equivalent. So if we solve one, we solve them both. All right. So next, we're going to break out the Weierstrass substitution, or the tangent half angle substitution. And I'm only going to be including the relevant parts of it. The relevant parts being what you get for cosine x with this substitution and what you get for dx with that substitution. And if you're interested in that substitution and why cosine x turns out to be that, I do have a video on the Weierstrass substitution that I will post in the video. Um, it's pretty easy to figure out yourself though. Just let u equal tangent x over 2, and you will see you can get cosine x is equal to 1 minus u squared over 1 plus u squared, and that your dx would be 2 over u squared plus 1. All right, so we're going to plug that in to our I5. All right, so we just literally replaced cosine x with 1 minus u squared over 1 plus u squared, and we replaced our dx with 2 over u squared plus 1. And then we distribute the u squared plus 1 in the denominator there, and this is what we get. Okay. So next, we're gonna manipulate this a little bit more. So what I did here, well, it actually doesn't look like I did anything in this step, but what I did here, I expanded out u squared plus 1 squared. I expanded out 1 minus u squared squared. And then I gathered all our u to the fourth, u squared, and all our constant terms and just separated them. So next, what I did is, let's see, it looks like I multiplied or I divided the top and the bottom by u squared. And that might seem strange, but you'll see why I did that later. And then I separated, I grouped this a plus b times u squared plus 1 over u squared. And then we're just left with this 2 times a minus b. So I just regrouped it there. All right. And now it comes time for the substitution. W is equal to u minus 1 over u. You can do some algebra there and see that w squared plus 2 is going to equal to u squared plus 1 over u squared. And that's nice because we have that right there. And it also turns out that dw is 1 plus 1 over u squared du, and we have that right there. So now you can see why I performed the previous manipulations there. So now we can perform that substitution on our integral, and our bounds change from negative infinity to 0. And if you just go ahead and apply that substitution, and this is what you get. And then you can distribute and regroup to get this. And from here, this is you can evaluate this using pretty just standard anti-differentiation techniques. And evaluating that at the bounds will give you pi over 2 square root of a times a plus b. So that is the value of our fifth and seventh integral. So that right there is this and this. It's the value of that and that. And of course, we need to make sure that our a and b are valid. We don't want to get any negatives inside this square root or anything like that. All right, so what integrals are we going to take care of next? Let's do I6. That was equal to the integral from 0 to pi of 1 over a plus b cosine squared x dx. And we will split that up into two separate integrals, one going from 0 to pi over 2 and the other going from pi over 2 to pi, like that. Okay. And next, you can see what I did to this integral right here is I just subtracted pi over 2 from the bounds and added pi over 2 to all our x's inside the integrand there. And cosine squared of, well, cosine of x plus pi over 2 is sine x. I'm sorry, is negative sine x. So when we square that, the negative goes away and we're just left with sine squared x. So this is equal to this, which is, don't forget, this is I5, this is I7, and they're equal to each other. So that's equal to just 2 times I5. And since I5 was equal to this, I6 is just going to be pi over square root of a times a plus b. All right, what next? Let's solve I8, which is the integral from 0 to pi of 1 over a plus b sine squared x. Okay, well, we can use King's property to show that that's the integral from 0 to pi of 1 over a plus b sine squared of pi minus x. Sine squared pi minus x is just cosine squared x, and that is I6. So that is also equal to that. So now there's, I believe that's 4 of our integrals down already. All right, now let's do some of the easier ones here. I1 and I3. Well, first of all, I1 is this, and by King's property, it is also going to be equal to this. So I1 is equal to I3. We solved one, we've solved them both. Again, we're going to use the Weierstrass substitution here and only use the relevant parts. And we'll plug that substitution in. You can see I just plugged it in, changed our bounds and replaced cosine x with 1 minus u squared over 1 plus u squared, and dx with 2 over u squared plus 1. Then I distributed the u squared plus 1 and then grouped it like this. And from here, that is, again, that's that's kind of a trivial integral to evaluate. There are formulas for it that you learn in first semester calculus. And this is going to be equal to 2 over the square root of a squared minus b squared times the arctangent of the square root of a minus b over a plus b. So that is the answer to both I1 and I3. All right, 6 down, 2 to go. So let's take care of I2 next. That's the integral from 0 to pi of 1 over a plus b cosine x. All right, well, again, Weierstrass substitution. And again, I just plug it in, distribute, regroup, and from there it's very, very easy to evaluate that to pi over the square root of a squared minus b squared. All right, we have one more left. That is I4. And that is the integral from 0 to pi of 1 over a plus b sine x dx. And we're going to split that up as the integral from 0 to pi over 2 plus the integral from pi over 2 to pi. And then I'm going to take this one, subtract pi over 2 from the bounds, and add pi over 2 inside, and that's going to give us the integral from 0 to pi over 2 of a plus b cosine x. And that is equal to I sub 1 plus I sub 3, or just 2 I sub 1, however you like, because those things are equal to each other, and they happen to be equal to this. So I sub 4 is just 2 times that, which is this. All right, that's it. That's all the integrals solved. So just to finish it off right here, these are the integrals. So we have this integral is equal to this integral is equal to this. We have this is equal to this. This is equal to this. There's all 8 of the integrals right there. All right, and the reason I did 8 integrals in one video is because in my upcoming videos, I'm going to be using a lot of these formulas, and I just wanted to derive them all in one place, so I didn't have to keep doing them over and over again in future videos. Um, so anytime I use one of these formulas, I will link to this video, so people that have not already watched this video can see how they're done if they're interested. Anyway, guys, hope you enjoyed that, and we'll see you next time.